why do you look so down?
I want to prepare for the NMMS, but I have no idea where to start.
Oh,
Don't worry, I'm here to help. Gory Smart Channel has everything you need for NMMS prep. Just check it out. Subscribe, like, and share.
Really? That's awesome. I'll subscribe to Gowrie Smart Channel right away. Thank you so much.
Hi friends, I am Gauri Singha. You are watching Gauri Smart Channel. So today we are going to discuss about rational numbers. So it is the 8th class syllabus. So first lesson. This is the most very important lesson for number system. So in the number system, this is the basic concepts. So we will discuss today. In this rational numbers, each and everything will be covered. This video is useful for those who are present studying 8th class students and those who are going to write SSV exam, so 75,000 scholarship exam, and those who are going to write NMMS, National Means Merit Scholarship exam. So this video is useful for all competitive exams and also job oriented exams. Those who are getting, those who want to get, so teacher post or any other exam, SSC exam. So let us start our first lesson, rational numbers. So before going to discuss about rational numbers, first of all we have to know that natural numbers, whole numbers, integers, rational numbers, property, next number line and density property. So first of all we have to discuss these are all. First of all, natural numbers. What is natural numbers? So generally we are counting the numbers. Naturally we are counting numbers. So we don't put any efforts. So if I give some items, you will say 1, 2, 3 like that. Means naturally we are counting. So that's what counting numbers are called natural numbers. Counting numbers are called natural numbers. So in the natural number, the starting letter is N. The starting letter is N. So natural numbers are denoted with N. Natural numbers are denoted with N. N is equal to set of 1, 2, 3, 4, 5, and so on. In this natural numbers, we have the least number is 1 and we don't have the largest number. We don't have the largest number. And the natural numbers, what is the use of natural numbers means? For example, if I get the equation, if I give this equation, x plus 1 is equal to 1. Only use natural numbers, so solve this equation if I say, or verify this is satisfying or not. If I give only natural number system, you can't verify. Because, so what natural numbers if I take, then it will be satisfied. It will not satisfy. For that purpose, we need another number system that is called whole numbers. Why? Because here 0 is not there. If this equation is satisfying means we have to take, instead of x, we have to take 0. So 0 plus 1 is equal to 1. 0 plus 1 is equal to 1. So means for this equation is satisfying means we need another number system that is whole numbers. Because in the natural numbers 0 is not there. Because we are starting with a 1, 2, 3 and so on. Isn't it? Now, including 0 in natural numbers, then we can say that new system is called whole numbers. The natural numbers along with 0. The natural numbers, these natural numbers along with 0. See, 1, 2, 3, 4 and so on. Along with natural numbers. The natural numbers along with 0. The natural numbers along with 0 are called whole numbers. In the whole numbers, the starting letter is W. So we are denoting with W. We are denoting with W. Now, this number system can satisfy this equation. This number system can satisfy this equation. If I give, so satisfy this equation using any number system means we have to take this one. So the least one, the least number system is this one. Now, I will give one more example in the linear equation. This will also not satisfy. This will also not satisfy. Let us see. Now see here, I'm taking x plus y is equal to 0. I'm taking x plus y is equal to 0. What number if I take in this whole numbers, I will satisfy this equation, or this equation will be satisfied. If I take any number, it will not satisfy. Means we need another system. Means in the whole number, some numbers are missing. Some numbers are missing. What are those? These are all positive numbers. These are all positive numbers. We can say this is plus 4 or 4, simply 4. We can say this is plus 2 or simply 2. We can say this is plus 1 or simply 1. Means all our positive numbers are there. There is no negative numbers. So if I include the negative numbers in this whole numbers, then we will get the new system that is called integers. So the whole numbers along with the negative numbers, the whole numbers along with negative numbers are called integers. See here, and so on, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. The whole numbers along with the negative numbers are called integers. It is denoted with Z. Because Jahlon is a word, Jahlon means to count the numbers, to represent the numbers. So in the Jahlon, starting letter Z, so that's what we are indicating Z. So then why sir we are not indicating I sum is? So I means sometimes some books, irrational numbers it is denoting. So I. So that's what we are changing integers as Z. Okay. Now we got the new system. Now we have to check whether this equation is satisfying or not, because this equation is not satisfied by whole numbers. So that's what we have to check new system. Now see, in this minus 5 is there. In this minus 5 is there. Now instead of x, I will substitute minus 5. So minus 5 and plus 5, that is 0. That is equal to 0. So means 0 is equal to 0. Satisfied. Here also 1 is equal to 1. Satisfied. So I am very happy. I am very happy. Now if I study further, now I will take one more equation. 5x is equal to 3. 5x is equal to 3. Now I will say if this number system is satisfying this 5x is equal to 3. Is this system satisfy this equation? No, because if I take any value of integer, it will not satisfy the what I have taken the equation. Means in this also some numbers are missing. In this also some numbers are missing. So those numbers, if I include these integers, those numbers, if I include in this integers, then we get the new system that is called rational numbers. That is called rational numbers. Let us see rational numbers. So rational numbers are denoted with Q. I will see later. The numbers, if I take any two integers, and the second number must not be 0. The second number should not be 0. So if I take any two integers, and if I write the two integers in the form of P by Q, what are the P comma Q? P comma Q belongs to Z, where Q not equal to 0, So P comma Q are integers and Q not equal to 0, then the numbers which are in the form of P by Q are called rational numbers, P comma Q are any integers. In that integers, Q not equal to 0, Then the numbers which are in the form of P by Q, those numbers are called rational numbers. That is only our lesson. So in the SSV exam and NMMS exam also concept-oriented bits are given. That's what. So I am saying concept first day and second day. So application bits. So in the grand test also I will conduct. So about concept also, concept-oriented bits I will give. In the next day problems, top 20 problems I will say. In that application type bits and analysis bits and logical bits I will give you. Okay. So now P by Q form, the numbers which are in the form of P by Q, those are called rational numbers. So why sir rational numbers are denoted with Q? So rational numbers, see here, rational numbers are, but we are denoting with Q, because rational numbers means in the next classes you will get real numbers. You will get real numbers. So real numbers are denoted with R. So that's what we are changing this rational numbers. So rational numbers, why we are denoted with Q means, see here, I am dividing 8 by 2. Means if I divide 8 by 2, I am getting answer 4. I am getting answer 4. Or if I divide 9 by 2, I am getting answer 4.5. See, 8 divided by 2 means I am getting answer 4, and 9 divided by 2 means I am getting 4.5. So what is this 4 and what is this 4.5? Those are called quotients. How, sir? See, 8 is dividend, so 2 is divisor, so 2 4s are 8, so 0. So what is this answer? This is only answer. This is called quotient. This is divider, this is dividend, this is divider, this is quotient. So this is remainder. So this quotient, so in the starting letter of quotient is nothing but Q. That's what we are denoting with Q. If I take 9 also, I will get 4.5. That is the answer, 4.5. So that's what 4.5 is the answer. So that is nothing but quotient. The quotient starting letter is Q. That's what we are denoting with Q. So next number system, next equation also is there, but that is not there in our syllabus. That is next class in next class. So now we completed natural numbers, whole numbers, integers. So in this least number is 1, in this least number is 0, in this least number is undefined or can't say, undefined. In this largest number is undefined, in this also largest number is undefined or infinity, in this also can't say or infinity or undefined. Now in this also, so least number we can't say and largest number also we can't say. Now, so rational numbers also completed. Now rational numbers means those are positive numbers and those are negative numbers. All fractions are rational numbers. All fractions, what we have learned in the childhood, those are all called rational numbers. But all rational numbers need not be fractions. All rational numbers need not be fractions. Why means, in the rational numbers, there are positive numbers and negative numbers. But in fractions, only positive numbers only will be there. So negative fractions means negative dividend. So we can't do anything. So division of any item or division of anything, we can't do in negative. So that's what all rational numbers are need not be fractions. All rational numbers are need not be fractions, but all fractions are rational numbers. Now, again, these rational numbers are two types. So, if I divide numerator by denominator or if I divide P by Q, then I will get terminating decimals. Terminating decimals. Otherwise, non-terminating with the recurring decimals. With the recurring decimals. So, I can get terminating decimals. I can get non-terminating with recurring decimals. How, sir? If the denominator 2 or power of 2 means 2 square, 2 cube, 2 power 4, 2 power 6, 2 power 5, like that, any number. So, if the denominator 2 or power of 2 or 5 or power of 5, power of 5 or power of 5, or both powers, then definitely it will be terminating. Definitely it will be terminating. If the denominator is having 2 or power of 2, 5 or power of 5, or both powers, then definitely it will be terminating. Some example you see. See here, 24 I am taking, 2 cube I am taking, for your clear understanding. So 24 by 8. So 8 ones are 8 threes are. So 3. 3 can be written as 3.0. So terminating decimal. Or if I take 28. If I take 28, let us see. 8 threes are 24. So 4 will be there. If I keep point, so 40 will be there. Then 8 5s are 40. So 3.5 terminating. So means 2 or power of 2, 5 or power of 5, or both or power of both, then definitely it will be terminating decimal. Terminating decimal. Without this or including this, if any number is getting extra or if any number is not there, then those are non-terminating. Means, for example, 1 by 3 or power of 1 by 3. So 1 by 5, 1 by 6, 1 by 7, 1 by 9, like that. So other than this form, if anything extra is getting, or if like this, then those are called non-terminating decimals with recurring decimal. Non-terminating with recurring. For example, here I get 3. So this is non-terminating with recurring decimal. So we have to get only 2 or 5. Only 2 or 5, power of 2 or power of 5. So along with any number extra is coming, those are non-terminating with recurring decimals. Or without these numbers, if you get like this, so if you have, so denominator, so other than 2 power or other than 5 power, you will get non-terminating with recurring decimals. Example we'll see. So 1 by 3. So 0 point, so 10. 3 3s are 9. Again 10. 3 3s are 9 and so on. So 3 is recurring. 3 is recurring. So these are the rational numbers or two types, terminating decimals and non-terminating decimals. Now we are going to discuss about properties. So many properties are there. So about property, definitely one bit will be coming in NMMS and SSC exam. Definitely in the last year they have given property, using property. So one bit is given. So that's what now also we have to focus on properties. So if you focus on properties, definitely 1 mark will be in your pocket. Now we'll discuss about properties. Properties are there, those we will discuss now. So coming to properties, we have 3 important properties. So closure property, commutative property and associative property. Closure property, commutative property and associative property. And still 2 more properties are there, those we will discuss after this one. Closure property. So means what? Closure. So if you take any 2 numbers, if you do any operation, then result also close to the same number system. If I take any 2 numbers in any number system, that number system is important. The results also should be belong to that number system. So that is means close to that number system. So means friends or relatives. So those are called closure property. Means now look at the board. Now we are discussing about the rational numbers. Now I am taking 2 by 5 and 1 by 5. These 2 numbers I am taking. These 2 numbers I am taking. So if I add these 2 numbers, if I add, means addition, we are doing operation addition. If I add these 2 numbers, the result also will get rational numbers. I am taking 2 rational numbers, I am adding the 2 rational numbers, I should get the again result in the also rational numbers. Then that is called closure property, because it is close to the same number system. It is close to the same number system. That's what. So I am getting 3 by 5. So 1 by 5 and 2 by 5, that is 3 by 5. So 3 by 5 is also a rational number. So we can say that closure property is satisfying in rational numbers under addition. Closure property is satisfying in rational numbers under addition. In rational numbers under addition, because results also rational numbers. Now we will do multiplication. 3 by 2 into 4 by 9. See here, 2 2s are, 3 3s are. Again I am getting rational number. I am taking 2 rational numbers, I am multiplying, the result is also a rational number. So means it is satisfying closure law. It is satisfying closure law, because again I am getting rational numbers. If you take any 2 rational numbers, if you do the operation, then results also the same number system, then that is called closure law. Then that is called closure law. Next, subtraction. So 2 by 5, 1 by 5. So do subtraction. Again rational number. So means subtraction also satisfying closure law in rational numbers. So subtraction is also satisfying closure law in rational numbers. Now division. 2 by 7 is divided with 14 by 4 or 14 by 8. Now see here. So this can be written as 2 by 7 into 8 by 14. 8 by 14. So 2 8s are 16. So 14 7s are 98. So this is also rational numbers. So division is also satisfying closure law. Means closure law is satisfying in addition, multiplication, subtraction and division. With the operation addition, multiplication, subtraction, division. Multiplication, subtraction, division. So we are preparing for SSV exam, we are preparing for NMMS exam. So we have to concentrate on rational numbers properties. So natural numbers, whole numbers we know very well because in the early class we have studied very well because in 7th class it is a fast syllabus. So we completed that one. So we have to focus on only rational numbers because big numbers will be there in the fractions. Understand? Next, commutative property. Closely satisfying 4 operations plus, minus, into, division. Now commutative property is not like that. And associative property is also not like that. Only these two properties will satisfy only addition and multiplication. Operation of addition and operation of multiplication. These two only will satisfy. The remaining two will not be satisfied. Now let us look at them. 3 by 7 I am adding to 2 by 7. What is commutative property? If I add any number a by b to the c by d number, if I add any rational number to the another rational number, so the reverse process if I do, the second number added to the first number, what I get in the first stage, the same answer also will get in the second stage. Say here, a plus b plus c plus d is equal to c plus d plus a plus b. If I slap anyone, immediately they also will slap me. Means what happened here? So the same result will be happen. So what I am doing, what I am giving the result, the same result also giving that person. So means what we are doing? Commutative property checking. So it is satisfying or not? Yes, it is satisfied. Commutative property is satisfied. So that is a by b rational number is added to the c by d, then c by d rational number is added to a by b, then both answers will be same. Both answers will be same. Then only the commutative property will satisfy. Then only commutative property is satisfied. See, 3 by 7 plus 2 by 7 is 5 by 7. Now I will add 2 by 7 to 3 by 7. Now what I will get? So 5 by 7. See, here also 5 by 7, there also 5 by 7. Means commutative property is satisfying in rational numbers under addition. Now we will see multiplication. 2 by 5, 3 by 2. Here 3 by 2, 2 by 5. So 3 2s are 6, 5 2s are 10. Here also 2 3s are 6, 2 5s are 10. See, left side I am getting 6 by 10, right side also I am getting 6 by 10. Means commutative property is satisfying in rational numbers under multiplication. In these two failed. So commutative property is not satisfying rational numbers under subtraction, under division. Why sir? See here, so same example only I will say 3 by 7 minus 2 by 7 and 2 by 7 minus 3 by 7. Now see, 3 by 7 minus 2 by 7 means 1 by 7. 2 by 7 minus 3 by 7 means minus 1 by 7. Both are never equal. 1 by 7 and positive number and negative number never equal, because positive number is that side, negative number is this side, never equal. So means commutative property is not satisfied in rational numbers under subtraction. In division also same like that only. So in the division also same like that only. Means what? See here, already we have done 2 by 7 divided by 14 by 8. Okay. So what I got? 16 by 98. Now I will do reverse. 14 by 8 is divided with 2 by 7. Now see here, 14 by 8 into 7 by 2. So reverse I am getting. So 98 by 16. So means one fraction and reciprocal never equal. One fraction and one rational number and its reciprocal never equal. Means commutative property is not satisfied in rational numbers under subtraction, under division. Here also same thing, associative property. What is associative property? Means three numbers you have to take. A by B, C by D and E by F. These three numbers. Here also take three numbers. A by B, C by D and E by F. What you have to do means, first of all, add these two numbers and the result add to the first number. And here what you have to do? Add first two numbers and result to the last number. Then if these two are equal, if these two results are equal, then that is called commutative. That is called associative property. Means second and third number I am adding, the result is added to the first number. In the same way, first two numbers I am adding and the result added to the third number. If I get both results are same from left side and right side, then that property is called associative property. Under addition, I am taking under addition, so it is satisfied. Definitely it will satisfy. here also, in the multiplication also, I am multiplying two numbers with the first number. I am multiplying first two numbers with the third number. Then these results will be satisfied. Means associative property is satisfied in rational numbers under multiplication. In subtraction it will not satisfy, and division also it will not satisfy. In subtraction also it's not satisfy, and division also it will not satisfy, because so these two will get some answer. If I subtract, means one more answer will be there, here different answer will be there. So you can try it, no problem, because I have explained this example. So these are called closure property, commutative property, and associative property. And what are the two things? Existence of identity. Existence of identity means, if I take one rational numbers, means we can say this is called identity property also. Identity property also. If I take any rational numbers, if I add any number to that rational number, I have to get again that rational number on. That is called identity. So now we will discuss identity property and inverse property. Then after that, distributive property. Okay, now identity property. Three by five. If I add what number to this 3 by 5, I will get 3 by 5. So whatever the number you are taking, that is should be identified to itself. Then what number I have to add? If I add 0, so 3 by 5 plus 0 is 3 by 5. So it is identified with 0. So what number I am taking? So for getting the same number, that is 0 we are adding, so 3 by 5. So this 0 is called additive identity, because we are doing addition. So that's what this 0 is called additive identity. So I am there, same thing for me, what I will get? So same, my image only will be getting. So if I use mirror, so whatever the face is there, same thing reflect in mirror. So means here mirror is called identity element. In the rational numbers, identity element is 0. Identity element. So additive identity, we can say additive identity or identity element. Now, what number if I multiply, then I will get same number 3 by 5. What number? So with what number I multiply 3 by 5? With what number I multiply 3 by 5? I will get the same number. So the same number will be identified with what number? So 3 by 5 is multiplied with 1, then we will get 3 by 5. Means here, 1 is the identity element, 1 is the additive element. One is the identity element. So what is identity element? Multiplicative identity. Here 0 is called additive identity, here 1 is called multiplicative identity. These two important bits. So what is the additive identity in the rational numbers? 0. What is the multiplicative identity in the rational numbers? 1. These two bits are most very important. Next. Inverse. Whatever the identity element is there, that should be result. So here 0 should be results, here 1 should be result. Whatever the identity elements you are getting, that should be result. Means this is the reverse process. That's what it is, inverse property. Now see here, I have to 0. Now I will take 3 by 5. Now we are adding. So what number I am adding, I will get 0. For 3 by 5, what number I am adding to get 0? Means I have to take minus 3 by 5. Here 3 by 5 and minus 3 by 5 are inverse elements to each other. Here we can say that, so this is additive inverse. This is called additive inverse because we are adding additive inverse to each other. Now again I am taking 3 by 5. What number if I multiply to get 1? For this 3 by 5, what number I have to multiply with this 3 by 5? I will get 1. We know very well that is 5 by 3. This 5 by 3 is called reciprocal of 3 by 5. So these two numbers are reciprocal to each other. So 3 by 5 is the reciprocal of 5 by 3. 5 by 3 is the reciprocal of 3 by 5. 3 by 5 is the additive inverse of minus 3 by 5. Minus 3 by 5 additive inverse of 3 by 5. These four most very important for all competitive exam, especially SSV exam and NMMS exam. So NMMS exam it is very useful, and also SSV exam also most very useful. Next we are going to discuss about distributive law. Now see, A into B plus C is equal to A into B plus is a into C. Now I am multiplying this A to keeping left side. I am multiplying A to keep the left side. So this way this is called LDL, left distributive law, LDL. Now if I do multiplication right side, so B into A plus C into A. This is called right distributive law, right distributive law. This is left distributive law and this is right distributive. So these are the properties. Next, number line. So we can represent every number on number line. So like that, rational numbers also will be represented. Rational numbers also will be represented. What is number line? A line which is having numbers with equal intervals. A line which is having numbers. So 0, 1, 2, 3. See here, the gap between 0 to 1 same, and 1 to 2 same, and 2 to 3 same, like that. So this is called number line. In this number line also we can represent the numbers. We can represent the numbers. For example, I want to represent 1 by 3 because 1 by 3 is a rational numbers. We can represent rational numbers also in the number line. 1 by 3. How to represent 1 by 3? So 1 by 3 is clearly when we can say that less than 0. Less than 1 and greater than 0. Means it will be between 0 to 1. Between 0 to 1 means 0.3. Isn't it? So means what can I do? So 1, 2. Between 0 and 1, we have to divide 3 equal groups, 3 equal divisions. 3 equal divisions if you do, then this is called 0 by 3, this is 1 by 3, this is 2 by 3, this is 3 by 3. See here, this is 0 by 3, this is 1 by 3, this is 2 by 3, this is 3 by 3. Means 3 by 3 means 1 only. Now, 3 by 3 means here, this point is called 3 by 3. So, in the number line, from 0 to 1, this is called 1 by 3. So, like that, we can represent rational numbers. We can represent rational numbers. Now, last property, density property. Density means what? More. So, more and more means density in the physics. Isn't it? Means, density property means between any two rational numbers. If you take any two rational numbers, there exists infinite number of rational numbers. Then that is called density property. For example, see here 1, 2 I am taking. So 1, 2 also rational numbers. How sir? Means this can be written as 2 by 1, this can be written as 1 by 1. Means P by Q form. 2 by 1 can be written as 2, 2 can be written as 2 by 1, 1 can be written as 1 by 1. So between two rational numbers, there exists infinite number of rational numbers. Sir, 1, 2 between, how can you say so many rational numbers are there? See here. 1.1, 1.2, 1.3, 1.4 like that. 1.9. Next 1.11, 1.12, 1.13 like that. So 1.111, 1.222 like that. 1.121 like that. Infinite number of rational numbers can be written. So decimals are rational numbers, isn't it? Because every decimal can be written as P by Q. See here 1.2 that can be written as 12 by 10 rational number. So every decimal is a rational number. Every decimal is a rational. Every rational number can be written as decimals. So in the starting itself I told you, isn't it? Terminating decimal, non-terminating decimal. So like that. So between 1 and 2 only I'm writing in like this. Like this decimals means, so many decimals means it is having so much of density, So that's what it is called density property. So between any two rational numbers, any two rational numbers, there exists infinite number of rational numbers, then that is called density property. So this is students, today our lesson rational numbers, each and everything I explained, you understand very clearly I think. So definitely in this concept, one bit will be coming, and also I am going to give you grand test about this concept. So very logical bits, really you will surprise. So the grand test is super you will say. So like that I am preparing grand test. So about this concept, so the grand test will be in the description and also in the group. So please join the group. So in the group, if you join, you will get grand test, and you will get grand test solutions, and you will get ranks. Those will get 20 out of 20. How to write grand test? In the next, this ending video will get how to write grand test. That video you see, and you can write the grand test. Submit before 12 o'clock. So midnight of 12 o'clock, then you will get the rank. 20 out of 20, who will get? Those only will get rank. All India ranks, not district ranks, or not local ranks, or not state ranks. All India ranks will get, because our videos are watching by all states students. That's what you have to write before 12 o'clock. So 20 out of 20, who will get? Those only will get rank. And you can write the test up to you are getting 20 out of 20. So you can write so many times, no problem. So there is no one time, like 2 times or 3 times. How many times you want, that many times. But if you get 20 out of 20, leave it. So because if you write 20 out of 20 so many times, then you will be getting so lost rank. So the computer will take you so in the ending. So that's what, only write one time up to getting 20 out of 20. So if you get 20 out of 20, leave it. Okay. So this is the rational numbers lesson. So if you like this video, just like it, and if you want to share it, and please subscribe the new students to my channel. And if you have any doubts, so please keep in the comment section, and watch how to write this grand test. Watch the how to write grand test video. Thank you.
If you enjoyed this video, please like, subscribe, and share it.